So let us start. In the last video, this is the second video on vectors. In the last video, we have given an introduction to vectors and scalars. As I discussed, when you learn vectors and scalars, it would be helpful for both physics and math. So in the playlist, I am included under physics, but you can use it in both the subjects like physics and math. And you will be getting questions for the board exam in physics and math, in the common entrance test for physics and math, NEET only for physics, and JEE for physics and math. Okay, fine. Let's start. So in this video, I will be I will be discussing. So the last video I told in physics we discussed about quantities and qualities. So physical quantity, I define physical quantity. Any quantity which can be measured is called a physical quantity. Physical quantities are having different classifications. One is fundamental quantities and derived quantities. That's in units and measurements. So in this chapter, our classification is physical quantities are classified into scalars and vectors. So based on their direction, if there is direction to a physical quantity, that we call it as vectors. I'm sorry. If there is no direction, we call it as scalars. So what is a physical quantity? Any quantity which can be measured is called a physical quantity. Physical quantities are classified into two. One is scalars. Scalars are physical quantities having only magnitude but no direction. Vectors are physical quantities having both magnitude and direction. All these things we discussed in the last video. Now in this video, first thing I am doing is vectors representation. How you will represent a vector. That's what I am discussing. Representation of vectors. A vector is represented by a straight line with an arrowhead. The length of the straight line gives the magnitude of the vector. The arrowhead gives the direction of the vector. So this is a straight line with an arrowhead. The length of the straight line, see, this is vector A and this is B. The length of the straight line gives the magnitude and the arrowhead gives the direction of the vector. Understood? Now, this is the vectorial representation. But when we write it in your book, how do you represent a vector? A vector is represented by, this is the way it represents. This is the representation. Just 1 second. This is the representation of vector A. So this is the way we represent a vector. Understood? Now, vector representation we have understood. Now next what we are going to discuss is some more points we are going to discuss. One is equality of vectors. Next one is zero vector. Then unit vectors. See, equality of vectors. See, if two vectors are equal, they must be having the same magnitude and same direction. So, two vectors are said to be equal. Very important. They must be having the same magnitude and same direction. For example, this is one vector. This is vector A. This magnitude is same here. This is vector B. And the magnitude is same here and the direction is also same, then we can tell these two vectors are equal. This is known as the equality of vectors. Very simple. If two vectors are equal, means their magnitude must be same, direction must be same. All parallel vectors are equal vectors. See, parallel vectors must be equal. Now, zero vector. Next concept is zero vector. So what is a zero vector? From its name itself, you can tell a vector whose magnitude is 0 is called a zero vector. So there is no magnitude, but there is direction for zero vector. So there is no magnitude, but there is direction. Such vectors we call it as zero vector. What is the use of a zero vector? For example, let's say you are in front of your house and you are standing, but your plan is to go to a nearby place. See, this is your place and you are standing here, you are stationary here, but you are planning to travel in this direction. Then here we can denote a zero vector with direction like this, because you have a plan to move in that direction. Present situation, there is no magnitude, that we call it as zero vector. So what is a zero vector? A vector whose magnitude is 0 is known as a zero vector. Understood? So that is zero vector. That's also very important. Another point I am going to discuss is unit vectors. Very, very important. Even the later part like cross product, there is multiplication of vectors. See, we already discussed in the last video, vectors won't obey the ordinary rules of algebra. Like scalars, you can add 5 plus 5 kg mass plus 5 kg mass is equal to 10, 2 kg mass plus 2 kg mass is equal to 4. But 2 Newton plus 2 Newton cannot be 4, it can be 0 as well. I discussed in the last video. So the point I want to summarize is scalars obey the rules of algebra, obey the rules of addition, subtraction, everything. But vectors do not obey the rules of algebra. We will have to come up with new rules like for addition, multiplication, everything. Okay, so fine, we will be discussing later these points. Now, what I need to tell you is, so zero vector we are discussing, zero vector it is covered. Now I told you, unit vectors, fine, that is very important. So what is the unit vector? So what is a unit vector? A vector whose magnitude is unity is known as a unit vector. So what is the magnitude or modulus of a unit vector? 1. A vector whose magnitude is unity is known as a unit vector. Unit vector is having direction, but its magnitude is unity. Zero vector is having direction, but its magnitude is 0. So a unit vector, for example, is denoted by a cap. So if there is vector A like this, then a cap is a unit vector along the direction of vector A. This is a cap. We can take it as 1 centimeter. Then a cap, it is denoted by a cap. A unit vector is denoted by a cap. Okay. So what is a unit vector? A vector whose magnitude is unity is known as a unit vector. You are clear on that as well? Now very, very important point. See, in coordinate geometry, we have 3 axes. One is the x-axis, next is the y-axis, and the z-axis. You know this. I will draw here. This is your x-axis. This is your x-axis. This is your y-axis, and z-axis. This is your z-axis. So all these 3 axes are mutually perpendicular. This is 90 degree. This is 90 degree. This is, see, this z-axis is this. I cannot draw. That's why I have depicted like this. Z-axis means this is x, this is the negative x, right? This is negative x, this is negative y-axis, and this is positive z-axis. inside the plane of the board you have the negative z axis. This is z axis. So I will draw like this, and draw like this. This is minus z. Z axis means this is z axis, positive z axis, and negative z axis is penetrating into the board. Understood? So what I am trying to say is the unit vector along x axis, we call it as the I cap. Unit vector along x axis is known as I cap. It is denoted by small I cap. Unit vector along y axis, we call it as j cap, that is small j. And unit vector along z axis, we call it as k cap. This is really important. I, j, k. Unit vector cap. I cap, j cap. They are small letters. I, j, k. So what is the unit vector along x-axis? I. So what is the magnitude of unit vector along y-axis? 1. Magnitude of unit vector is always 1. So I, j, k. To summarize, today we discussed about equality of vectors. Equality of vectors means if two vectors are equal in magnitude and they have the same direction also must be same direction, we call it as equal vectors. What is a zero vector? A vector whose magnitude is 0 is known as a zero vector. When do we use? See, one object is stationary and it is planning to, in future it will be moving in a particular direction. There we will introduce the concept of zero vector. Then next is unit vectors. A vector whose magnitude is unity is known as a unit vector, and unit vector along x-axis is I cap. Unit vector along y-axis is j cap, and unit vector along z-axis is k cap. Clear? And one more point I want to tell you is equality, representation of vectors. See, how do you represent a vector? A vector is represented by a straight line with an arrowhead. Understood? And the length of the straight line gives the magnitude of the vector, and the arrowhead gives the direction of the vector. Okay. Now next is that is this is the way you will represent. This is vector A, right? So this is the this is the way when we write it in your notebook or textbook. This is the way we represent. The vectorial representation is a straight line. The magnitude of the length of the straight line gives the magnitude, and here you will write the arrowhead gives the direction. This is vector A. So this is representation of vectors. So that's all for today. Thanks for watching.